Hey everyone, I hope you guys have been enjoying the last few videos and are understanding the basics of fractions that we've started talking about in this unit. Um, Most recently we talked about how to go from an improper fraction to a mixed fraction or a mixed number, right? Um, So we've already dealt with proper fractions. Proper fractions are sort of the easiest to deal with because you don't have to worry about converting between these different types um, for different types of questions. But so we've already talked about going from improper fractions to mixed numbers, and in this video we're going to go from mixed numbers to improper fractions. So we're going to go in reverse this time. Now this might be a bit of a long one because we've got a few things to get through, but if we're not getting through all of them, then I'll cut it short and pick up wherever we leave off in the next video. So we're going to start off this lesson with going from mixed numbers to improper fractions, and then we're going to start working on addition of fractions, which isn't a particularly difficult concept, but there are a few details that you kind of have to watch out for. So we're gonna take that a little bit slow to begin with. And then if we have time in this video, we'll talk about how to add, we'll start with adding and subtracting proper fractions, and then we'll move on to adding and subtracting mixed numbers or improper fractions and what to do in those cases. So we'll start by going from mixed numbers to improper fractions. So we're going to start by doing converting mixed numbers to improper fractions. So that's where we're starting today. So we're going from mixed numbers to improper fractions. So basically what that means is, let's start with, I'll just write a mixed number on the board. So let's say something like, let's say 2 1/3, something like that. Alright, so that's the improper fraction, sorry, that's the mixed number that we're dealing with, and we want to turn this mixed number into an improper fraction. So basically what this type of fraction is telling you is that if we go back to the pizza and pie analogy that we've been using in the last few discussions on fractions, is basically what this is saying is that if I had a bunch of pies in front of me and I told you that the number of pies I had was represented by this number, that means that I've got two complete pies that, you know, haven't been cut, nobody's touched them or eaten them or anything like that. Two complete pies, and then I have another pie that's cut into thirds, but I only have one of those thirds. So I only have one of those three pieces from that pie over there. So I only have, let's say if I shade in what I have, I've got one complete pie here, I've got a second complete pie over there, and then I've got 1/3 of a pie like this. So that's basically what this fraction is telling us, is that if you have a bunch of pies in front of you and I tell you, well, how many do you want, or how many do you have, and you say, I've got 2 1/3, that means you've got two pies that nobody's cut them, nobody's touched them, nothing like that. And then you've got one extra slice of pie, where that slice, this is the important part, is that where that extra slice is 1/3 of the whole pie, right? If I had a pie that looked like this, and I had one slice of that, just because I've got one slice doesn't mean I have 1/3 of the pie, right? In this case, I've cut the pie into 1, 2, 3, 4, 5, 6 pieces. So if I only have one of those 6 pieces, that means that this diagram right here is representing 1/6 of a pie, right? So the important thing that you have to remember is that this denominator here has to reflect how many segments you've cut your pie or your pizza into, right? If I had a different number at the bottom, if I had 5 or 7 or 8 or something like that, that tells me how many slices did I cut this pie into first, and then the numerator is telling me how many of those slices do I still have left, right? So 2 1/3 means I've got one of those pieces. 2 2/3 would mean that I've got a second piece like that one, right? I've got 2 whole pies, and then I've got this extra second piece of pie. But I'm going to go back to this 2 1/3. Sorry if I made you erase and rewrite something there. But basically, we're going to take this 2 1/3, and what we're going to try to do, let me get rid of this, is we're going to try and turn this mixed number into an improper fraction. Oops, got rid of the 1 there. Didn't mean to do that. So we're going to try and turn this mixed number into an improper fraction. Now, an improper fraction, this is not the same improper fraction as this one, but if I give you an improper fraction like 17/4, what that is telling me, if I've written it as a mixed, if I've written it as an improper fraction, this is telling me that, okay, if I have a bunch of pizzas and I've cut them all into quarters, I've got a bunch of pizzas or a bunch of pies, and I've cut them all into quarters, this 17/4 is telling me that if all the slices are 1/4, 1/4 of the whole pizza or the whole pie or whatever, then I have 17 such slices. So if each piece, each slice is 1/4, 1/4 of the pizza, I've got 17 of those slices. So that would mean, in this case here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And so for this one, this is going back to what we were doing last time, I could convert this from an improper fraction into a mixed number. And I would turn this 17/4, well, you can see I've got one hole there, I've got a second hole here, third hole here, fourth hole here, and then there's one extra slice over here. So I've got 4 holes, and then I've got one extra slice, and that extra slice is 1/4 of the entire thing. So that's why my denominator there is a 4. So what we've just done with this 17/4 is we've gone from an improper fraction to a mixed number. That's what we were doing last time. But I'm doing that again because I want to highlight the difference in what these two things mean. Basically, the difference in how you can think about them. With this 17/4, that's saying, okay, you've got 17 slices of pizza where each slice looks like a quarter of the circle. You've got 17 of those slices in front of you, and then I come up and I ask you, okay, if you put those slices together, how many complete pizzas could you make, and what would you have left over? So with this 17, is I'm giving you the slices, and I'm asking you to give me the holes. If we're going from a mixed number to an improper fraction, that's me giving you 4 pizzas and then that extra slice, and I'm saying if you cut all the pizzas into quarters, how many slices will I have? So that's sort of the difference. Hopefully that's making sense. It's a little bit hard to gauge whether this would be something that's making sense to you guys, because obviously these are all pre-recorded, but so that's, hopefully you guys are able to make that you're able to distinguish the meaning of the improper fraction from the meaning of the mixed number. So I know I've got a lot of stuff going on here. Let me get rid of the 17/4 and all that stuff. If we go back to this 2 1/3, so now what I've done is, I've still colored in the 2/3 over there. So we've got this 2 1/3 pies. So I've put 2 pies in front of you that nobody's cut, nobody's touched, nobody's eaten, and then I've given you one extra slice of pie that I've told you this is 1/3 of the pie. The other 2/3 are gone. Somebody ate them. And now I'm saying somebody's coming and they want these pies to be cut into thirds. They want each pie to be cut into 3 slices for all the complete pies that you have. Can you tell me how many slices we're going to have once you're done the cutting? And so basically what I'm going to do is I'm going to take this first pie, right, and I'm going to cut it into thirds, right? Now I haven't eaten or lost or thrown away any of the pieces, so I've gone from having one hole over here to 3 thirds, right? I've got 1/3 right here, I've got a second third over there, and I've got this third third at the bottom. So I've got 3/3 of a pie from that whole, right? So I just took one of the whole pies and I just cut it into 3 slices. So I've turned it from 1 into 3/3, right? I'm going to do the same thing with the second whole pie. So I've taken that and I've cut that into thirds, but again, I haven't eaten any of it, I haven't thrown any of it away, so I still have the entire pie. I still got 1, 2, 3/3. I've still gone from starting with one whole and turning it into 3/3 of a pie. 3 slices where each slice is 1/3 of the pie. So remember that this numerator 3 means that's how many slices I have, and this denominator 3 is telling me each slice makes up how much of the pie. So if it's a 3, it makes up 1/3 of the pie. If it's a 6, it means it's 1/6 of the pie, things like that. So now I've got 3/3 over here, and I've got 3/3 over there, and I still have that pie that was only the one extra slice, right? I only had the one extra slice. I'm not going to change it or cut it or do anything to that one. So what I've done is, we started with, if you ignore this stuff at the bottom, we started with 1 pie, 2 pies, and 1/3 of a pie, right? That's this mixed number that we've got over here, is that we've got 1, 2, and 1/3. 2 and 1/3. Now what I've done is I've taken the whole pies and I've cut them so that everything is cut into thirds. All I have is thirds of a pie. I don't have any complete whole pies anymore. So that means we're going to be converting this into an improper fraction, because if I don't have any complete pies, you know, uncut pies or anything like that, I'm not going to have any whole numbers. So what I want to do now is I want to say, okay, well, everything is cut into thirds. That's the important part, is that you want every piece of pie to be the same amount of pie. I don't want to have 1/3 here and 1/4 over here and 1/8 of a pie over there. I want them all to be thirds, or all quarters, or all eighths. Since the mixed number already told me I'm dealing with thirds, I've cut all the whole pieces into thirds as well. And so now I just need to count how many slices I have. So from the first pie, I've got 3/3, so we've got 3/3. Alright, hopefully you can see that. From the second pie over there, I've got another 3/3, so I'm going to add that on. And then from this leftover pie, I had just one extra slice, so I've got plus 1/3. Now we're going to focus a little bit later on adding and subtracting fractions. I may have accidentally sort of thrown a little bit of this your way before we actually got to talking about adding fractions, but one thing you got to remember, really the only thing you have to remember if you're adding proper fractions, is that once the denominators are all the same, you don't have to worry about them. So my answer, if I started with a whole bunch of thirds here, and a whole bunch of thirds there, and a whole bunch of thirds there, my answer is also going to be expressed in thirds. So that's sort of the big thing with adding proper fractions. And then with this numerator, well, we're really just with adding fractions. As long as the denominator is the same, that denominator just carries over to your answer. You're not going to add these or multiply them or anything. But then with these numerators, we've got a 3, we've got another 3, and we've got a 1. Right? And so that's telling me, okay, I had 3 slices of pie from the first one, I had 3 slices of pie from the second one, and I had 1 slice of pie from the third one. How many slices do I have in total? We just add up those numerators. 3 plus 3 plus 1. We just add those together and we get 7. So this 7/3 over here, that's our improper fraction that we were targeting from our 2 1/3. That's how you turn it into this improper fraction over here, which is 7/3. And if you try and do this in reverse, following the techniques that we talked about last time with going from improper to mixed, you should get that 7/3, when you convert it back, gives you 2 1/3 again. Now, that's a bit of a long process, right? This video is already 14.5 minutes in. That's a bit of a long process. So we want a shortcut, a shorter way to go about this type of problem, especially if you're dealing with larger numbers. and more complicated fractions. If I give you a fraction where you've got 52 wholes, so you've got like 52 pies, and then each pie is cut into 157 pieces, you're not going to be sitting there and drawing it out and cutting them all into 157 separate little pieces. You want a shortcut. So we went through it that long way so that you understand why the shortcut works. But basically what we did is we took this 2 1/3, and we know we're dealing with thirds. So because we want everything to be in terms of that denominator, I take this whole and I chop it up. I chop each whole up into as many pieces as what this fraction is representing. So this fraction, if that's not clear, basically what I'm saying is this fraction is telling us that the leftover pieces we have are thirds of a pie, right? This could be 1/3, this could be 2/3, doesn't matter. If we had a different denominator here, a 5 or a 7 or something, that would change what we're talking about. But for 2 1/3, what this is telling us is the fraction is telling us that the leftover pieces of pie are cut into thirds. So what we want to do, because we want everything to be, every piece to represent the same amount of pie, is we're going to cut the 2 wholes into thirds as well. So if you remember, what we did is we said that, okay, well, 2 is the same as 1 + 1, and then we cut those 1s into thirds, and so we got 3/3 plus 3/3, right? And then we just tacked on that 1/3 that we had at the end, that sort of carried over, and then in our final answer, we just, to get our final answer, you just add up the numerators of those fractions. But what we did, what I want to focus on, is we took that whole number, that 2, we broke it up into its individual components, 1 pie here, 1 pie there, and then for each pie, we cut it into some number of slices, and that number of slices was dictated by the denominator of our fraction. And so if you notice, what you get is, if you cut 2 pies, so we've got this 2 pies here, if you cut that into thirds, if you cut 2 pies, or you cut each pie into thirds, the thirds is dictated by that denominator, you're going to get 6 slices of pie, right? You have 2 pies here, and then you cut each one into thirds, and then you count how many pieces you have. You've got 1, 2, 3, 4, 5, 6. You get 6 thirds of pie. So you get 6 thirds, right? And then we had 1/3 left over from, whatever, it's just we had that extra bit of pie. So we had this leftover 1/3, and then this gives us that 7/3 that we got as our final answer from before. Right, so basically the thing I'm trying to get across here is that notice that this 6 down here is equal to 2 times 3. That's not a coincidence. So this whole number times the denominator gives you this sort of fraction that you can start with, and then you have to sort of add on that extra bit from whatever this numerator was, however many leftover pieces you had. So you take the number of wholes, cut them up into thirds, or if the denominator was different, you'd cut them up based on what the denominator says, and that's going to give you some number of pieces of pie. And then you're going to add on whatever was left over, whatever that fraction is telling you, that proper fraction, whatever it's telling you, you add that on to the end, and then you put everything together, and you get your answer. Hopefully that's making sense. We're going to do a couple more examples now, just sit tight. But basically, the thing I want to point out is that this 6 over here is not a coincidence. This is a direct result of the fact that we took 2 pies and cut them into thirds. Why did we take 2 pies? Because we started with 2 complete pies. Why did we multiply this by 3? Because we cut each pie into thirds. Alright, so hopefully that's making sense. And then that 1/3 over there just came from the extra 1/3 of pie that we had left over before. So we used up all 3 pieces of information that were given to us in the fraction. We used how many wholes we have, what number of, or how many, cuts to make, what portion of a whole each slice represents, and then how many extra slices did we have. So those were the 3 pieces of information. How many wholes, how many pieces per whole, and how many pieces we have extra. So what we're going to do is we're going to go through an example or two. And we're gonna see, this is a mess right now, so let's go through another example, and as I walk through it with this next one, you should hopefully start to see a little bit of a pattern. And then in the last one, I'll show you sort of the algorithm that you can use, the formula that you can use to just quickly get the answer without having to think of pizzas and pies and things like that. So for this next one, we're going to take 4 and 2/5. Alright, and I'm asking you, okay, so you have a pie. For now, we'll stick to the pie analogy, and then in the next example, we'll try and drop it. So, you've got a pie that's cut into 5 pieces. Why 5? Because of this denominator down here. Alright, so we've got a pie, each pie is going to be ultimately cut into 5 pieces. Right now what we have though is we've got 2/5 of a pie. So I've cut one of these pies into 5 pieces. I've got 2/5 of that pie, like so, right? 2/5 because of that numerator up there. So I've got 2 pieces of pie that aren't part of any whole. But then on top of that, this 4 is telling me that I've also got 4 complete, uncut, untouched, uneaten pies. Right, so this is what my picture would look like, and if I shade those in, you know, then we've got our 4 complete pies. That's 1, 2, 3, and 4. And then we've got this 2/5 of a pie over here, extra. And so ultimately what we want to do is we want to take each of these 4 uncut pies and we want to cut them all into fifths. Remember, we're cutting them into fifths because our denominator in the mixed number is 5. That's why we're cutting them into fifths. And let's deal with just the 4 whole pies first. We'll ignore this 2/5 extra. If we just count the slices that we have here, we cut the entire pie into 5 pieces. We cut it into fifths, and we need 5/5 to make a whole. So we've got 5 slices there. Now, in the second pie, it's the same deal. We had an entire pie, cut it into fifths, but we still have the whole pie, so that means we must have 5/5. And it's the same thing for the third one. We've got 5/5, and it's the same thing for the fourth one, 5/5. And you'll notice if you sum all of those up, you add all of those together, you'll get that from the 4 complete pies, when you cut them into fifths, you get 20 slices of pie. And if you notice, for those of you who are good at noticing these patterns, you'll see that that 20 comes from 4 times 5. We've taken each whole pie and cut it into 5 pieces. So the number of pieces that we have is the number of holes we have times the number of slices in each whole pie. So we've got 20 slices from those holes, but we don't want to forget about the extra slices that we were also given. So from those extra slices, we also have 2/5 of a pie. Now, I'm not writing 2/5 down here, I'm just writing a 2, because this 5, 5, 5, and 5, those are all representing slices of pie, right? I'm not going to say I've got 2/5 of a slice of pie. I've got 2/5 of the whole pie, but because the pie is cut into fifths, that 2/5 means that I have 2 slices. Alright, I know that was a lot of words and a lot of numbers, but hopefully that's making sense. In that, so basically all I'm talking about here is the number of slices. We're not talking about fractions or anything like that yet. We've just said, okay, I had 4 pies, I cut them all into 5 pieces, so I've got 5 slices, 5 slices, 5 slices, 5 slices. That's 20 from there. And then I had 2 slices from this extra one, so I had my 20 slices over there, my 2 slices over here, so that is going to mean that I've got those 20 slices from before, plus the 2 extra ones, means that in total I've got 22 slices of pie. But that's not giving us a fraction, and we know that obviously 4 and a little bit is not the same thing as 22. Here's where you got to remember that each whole that we've written down here, this 5, isn't really 5. This is 5/5 of a pie. So really, this should be 5/5. It should be 5/5, right? And then over here, we've got 5/5 of a pie. Here we've got 5/5 of a pie. here we've got 5/5 of a pie, and here we've got 2/5 of a pie. So now what we've got is we've got 22 slices of pie, but I didn't ask for how many slices we have. I wanted, well, I mean, that's the way I was wording it earlier, but this, when you're going from a mixed number to an improper fraction, I'm not asking how many slices do you have. I'm saying how many portions of the pie do you have, right? So I'm asking you to express your answer in terms of the number of pies that you have, not in the number of slices that you have. This might be getting a little bit confusing. I'm not wording this in the best way that I could. But basically, this 22 slices is not your final answer because each slice is 1/5 of the pie, right? That's what you got to remember, is that each slice of pie is 1/5 of the whole. So even though we had 20 slices and then we added on those extra 2 to get our 22 slices, what it really means is we've got 22 slices, but each slice is 1/5 of the pie, so we make it 22/5. Alright, so hopefully you sort of followed how I did that. We counted the number of slices that we have, and then we ask ourselves, okay, well, each slice makes up how much of a pie? And we got that it gives us, that each slice is 1/5 of a pie, so we make it 22 slices, but each one is 1/5 of a pie, so that's why that's our denominator. And then you get that 4 2/5 is 22/5. Alright, hopefully this is making sense. If not, we'll do one more example, and for this one, I'll show you the shortcut, and we'll just solve it using the shortcut. And we might actually, just so that all the addition and subtraction stuff sort of stays together in the same lesson, we might cut this one short at the end of this converting mixed numbers to improper fractions, and we'll pick up with addition and subtraction in the next video. But so we'll do one more example. I'm hoping that this whole analogy with the pies is making sense. For me, honestly, I never really preferred the whole pie and pizza discussion, but I find that a lot of people do find it helpful to sort of visualize it that way. I'm actually going to leave that 22/5 there for a sec. So yeah, I tend not to prefer this pie and pizza thing, and you're taking these holes and you're chopping them all up and things like that. I don't really prefer that. I learned the shortcut, I understood why the shortcut worked, and I just kind of went with it, and I never really looked back. So if you can, I'll show you the shortcut. My hope with the pie and pizza analogy was that you understand why we're doing what we're doing when I show you the shortcut, because I don't want you to be using the shortcut and not understand why. Because if you don't understand why you're doing what you're doing, that's when it's easy for you to make a mistake. If I say, oh, you just multiply these things together, but you don't get why we're multiplying those things together, you might not remember how to do it when it matters. And I'm not saying when it matters like in the sense of a test. I'm saying when it matters that, like, I don't know, anything comes up and you have to do math. If you remember the steps but you don't understand the steps, then it gets that much easier to make a mistake. If you think you remember the steps but you don't really know why you're doing them, that's when you'll make a mistake. So what I'm going to do is I'm going to point out a connection with this example and also with the last one. We did 2 1/3, and then we'll use that pattern to solve the last one, the last example that we'll do in this video. So in this second example, remember we started with 20 slices of pie, and then we had those extra 2 slices of pie, and that was all fifths of a pie. So I'm just going to put that as a denominator over 5, right? So we ended up ultimately getting 22/5 as our answer, and that came from us having 20 slices of pie from the 4 holes, plus the 2 extra slices of pie that we were given in the question. And in the previous example, when you cut the 2 whole pies into thirds, you get 6 slices, but then we also had that extra 1 bonus slice, and those were all thirds of a pie. So we make our denominator 3. So one thing you should notice is that this denominator in the mixed number and this denominator in the improper fraction are the same, right? The mixed number and the improper fraction, the denominator does not change. So honestly, when we go through the shortcut, you can kind of ignore the denominator. Like you can ignore the fact that you're dealing with fractions because the denominator doesn't really affect how you do the problem. It affects your calculations, obviously, because it's one of the numbers that we use, but you don't have to stress yourself out with, oh, I gotta remember that I'm dealing with fractions and this and that. Don't stress out about the denominator. Just make sure that your denominator in your mixed number is the same as your denominator in the improper fraction. And another thing I want to point out, well, two things I want to point out, is that this numerator in the mixed number is the same as that little bonus thing that we add on over there, right? And this numerator of a 1 in our previous example is the same as that bonus slice that we added on over there. And so that's two of the numbers that we've used now, right? We've used the denominators, taken care of, and we've used this numerator, this 1 in the first example and this 2 in the second example, and those are accounted for everywhere. The only thing that we haven't accounted for is that pesky 20 from our last example and that 6 from our very first example. And if you notice, this 20 in the example we just did comes from 4 times 5. That's how we got the 20, was we had 4 pies, cut them into 5 pieces each, that gave us 20 slices. And this 6 over here came from 2 pies cut into 3 slices each, which gave us 6 slices, plus the bonus slice gave us 7 slices of pie. And then in the second example, the 20 slices came from the 4 pies, plus the 2 extra slices, which gave us a total of 22. Now, if you're writing this down and you're trying to keep all of this straight at the same time, I apologize. I know there's a lot of circles and a lot of arrows and stuff on this, but basically, what you get is, I'll show you, I'll erase this and I'll show you the shortcut in a fresh example, and then we'll do that one and possibly another quick one after that, and then we'll call it a day for this video, and we'll pick up with addition and subtraction of fractions in the next one. So, basically, let's do, what did I write down? I wrote down 8 and 5/9. Alright, this is the next one that we want to convert. Now, I don't know about you, I don't really feel like drawing 8 pies and then drawing an extra 5/9 of a pie. I don't even know how to draw ninths and make it look like they're all the same size. And then I don't want to take those 8 pies and cut them all into 9 slices and then color them all in. My marker's going to run out of ink by the time I get to that. So what I'm going to do is I'm going to show you the shortcut. Now if you remember, when we had our 4 2/5, we start by taking that 4 pies and we cut them all into 5 slices each, which gave us 20 slices of pie. We added on that extra 2 slices that we were given, and then we had to remind ourselves, oh right, we had 22 slices, but they were all fifths of a pie, so that's our denominator. So the 20 plus 2 obviously gave us 22 over 5 pies. Now, with this 8 and 5/9, basically, what's happening behind the scenes is I'm taking those 8 pies and I'm cutting them into 9 slices each. Now, if I cut 8 pies into 9 slices each, that should give me 8 times 9 slices, right? That should give me 8 times 9 slices. If I take 8 pies and I cut them all into 9 pieces, then that should give me 8 times 9 slices, whatever that number is, which we'll figure out in just a sec. But then on top of that, we had the 8 pies, we've cut them all into 9 slices. That's going to give us, for those of you who are itching for the calculation, is 72 slices of pie. But then we also have this bonus 5 slices of pie that we've been given, for whatever reason. So we've got that 8 times 9 slices, plus this bonus 5. Right, that's how many slices of pie we have. But each slice represents 1/9 of the pie, so we put a line, and our denominator is a 9, because each slice is 1/9 of the pie. So this is sort of what's happening, that's sort of the reasoning of why we're doing this behind the scenes. But if you notice, the shortcut is you've got this denominator and this whole number are just multiplied together over there, and then you just add on whatever the numerator is, right? So if you've got, I'm going to write this with letters and see if you understand it, great. If you don't, I'll rewrite it in a sec. But basically, if you have A and B over C, where both those are all just numbers, if this isn't making sense, don't write it down. I'm going to write it a different way in a sec. So you've got A and B over C. That looks like a mixed number, right? A would be some number, B would be some number, C would be some number. To turn that into an improper fraction, you're just going to multiply the whole number and the denominator, and then you're going to add the numerator to it, and you're just going to keep the denominator the same. So if you're understanding this line at the bottom that I just wrote, feel free to write that down. If you're not understanding it, I'm going to write it out with words so that you can see what exactly this shortcut is. But basically, you take your whole number, multiply it by the denominator, and actually I like to say that in the reverse order. I'd like to say that it should be denominator times the whole number, and then you add on the numerator, because for that then you can sort of draw this arrow to remind you that you start with this denominator and then you just go in one direction. You go clockwise and you do denominator times the whole number plus the numerator. So first you do multiplication, then you do addition. And so what you get is, here's our denominator, that 9, times the whole number, that's our 8, which is going to give us 72. And then we got 72 plus 5 is going to give us 77 over, and then our denominator just sort of comes along for the ride. That 9 stays the same here, stays the same here. And you get a final answer of 77 over 9. Now if you're not appreciating this thing with the letters at the bottom, let me just quickly rewrite it a sort of different way. The improper fraction for a mixed number, the way you get it is you do the denominator of your mixed number times the whole number plus the numerator. I'm slightly running out of space, all over whatever denominator you started with. So that is sort of a formula, sort of expression type thing that you can follow to turn a mixed number into an improper fraction. Is that you take the denominator of your mixed number, multiply it by the whole number, and then once you have that product, add the numerator of your mixed number to it. So like if we follow that for this process, we've got denominator times whole number. That's going to be 9 times 8. So that's going to be 9 times 8 denominator times whole number. That's what we have up here. 9 times 8, that's 72, plus the numerator. So that's 72 plus 5, that's plus this numerator, is 77. And then that denominator just comes along for the ride. That 9 follows all the way through. And we get an answer of 77 over 9. So if I leave that there, we'll wrap up with one last quick example. I know a couple of these have been a little bit longer than I would have liked. I didn't want to stretch them to the entire duration of your class because, you know, it takes time to set up and things like that. But let's do one fresh example. Let's do something like 7 and 1/6. Something like that. Alright? So we've got 7 and 1/6, and we want to turn this into an improper fraction. So the way you do that, let's set it up according to this expression down here. We've got denominator. Alright, denominator times whole number. Well, our denominator is the 6. So we've got denominator times whole number. So our whole number is 7. So 6 times 7, whatever that is, plus the numerator. Our numerator is 1. So we'll do 6 times 7 plus 1. And then our denominator just comes along for the ride. We rewrite the same denominator that we had before. And so what we get is 6 times 7 plus 1 all over 6. Whenever we figure out what that numerator is, that'll just be the numerator of our improper fraction. So this 6 just carries over. This 6 in the denominator carries over there and carries over there, and we get a 6 down there. That much we know. Up top we get 6 times 7 is going to be 42, plus 1 is 43. And so then you've got your final answer. You've converted this mixed number here, 7 1/6, into that improper fraction over there. And so you've turned 7 1/6 into 43 sixths. Or if you don't like saying sixths, then 43 over 6. So hopefully that's making sense. We'll do a little bit more with mixed numbers. If you guys want an extra video on how to convert improper to mixed, or how to convert mixed to improper, or anything like that, then I'd be happy to make an extra one. Otherwise, next time we will discuss adding and subtracting fractions, and then hopefully also how to add mixed numbers and things that get a little bit more complicated. But yeah, hopefully this is making sense, and I will see you guys in the next video. Have a good one.